Assalamualaikum and hi everyone. In this video, we will present the examples of Newton's laws in daily life.
Newton's first law states that if a body is at rest or moving at a constant speed in a straight line, it will remain at rest or keep moving in a straight line at constant speed, unless it is acted upon by a force.
One of the examples of Newton's first law that we can see is through car accident.
At this point, the car and the driver is moving at the same speed. When an external force from the block is acted on the car stops moving. The driver remains moving at the same speed until a force is applied. The driver stops moving as he hits the windshield. This is called inertia.
When we were cycling, the bike will move if we pedaling the bicycle. But if suddenly we stop pedaling, the bike will still continue to move until the friction or gravity slows the bike down.
The last example of application of Newton's first law, which is inertia in our daily lives, is how the catapult works. For the reference of structure of catapult, you may look up to the diagram displayed. The pulling force is exerted on the arm, which adjusts its position. When the force is released, the arm will spring back to its original position. The payload in the bucket follows the movement of arm to its original position. However, the inertia in the payload causes it to remain moving at the same speed until an external force is applied to the payload.
Newton's second law states that the rate of change of momentum of an object is directly proportional to the force applied.
The first example that demonstrates Newton's second law of motion is the acceleration of objects under different circumstances. Based on the diagram, if the force applied to the cart is the same, the acceleration of the empty cart is greater than the acceleration of the loaded cart. In other words, when the mass increases, acceleration decreases. Secondly, if the mass of the object is kept constant, the acceleration will increase when a larger force is exerted. Therefore, acceleration is directly proportional to the magnitude of force applied.
For example, pushing a rock by human and machine. Forces exerted by both human and machine are external forces which causing the rock initially at rest to move. Different forces exerted on the same mass produce different accelerations. Since the rock that is being pushed is the same, therefore mass is constant. In simple terms, Newton's second law of motion states that if force is applied to any object that has mass, it will result in the production of an equivalent amount of acceleration in the object. Hence, a smaller force causes a smaller acceleration as compared to a larger force. In this case, forces exerted by human is known as the smaller force, while forces exerted by the machine is known as the larger force. A machine is able to push the rock further than human, as machine can exert larger force onto the rock.
Why the cricketer lower his hand when catching the ball is by lower his hand, he will increase the time taken to catch the ball. So, when the time taken increase, the rate of change of momentum decrease. So, the force exerted by the ball to the cricketer's hands will decrease. Hence, less impulsive force exerted on the cricketer's hand.
Thus, the cricketer can catch the ball safely.
Newton's third law states that when two bodies interact, they apply forces to one another that are equal in magnitude and opposite in direction. The third law is also known as the law of action and reaction. This law is important in analyzing problems of static equilibrium, where all forces are balanced, but it also applies to bodies in uniform or accelerated motion.
Motion of a rocket. A rocket is launched using hot gases. To produce the hot gas, different kinds of fuels are burned in the rocket engine. After the fuels are ignited and burned, the gases escape from the bottom of the rocket. These gases flow downward, which is the action force, and and the rocket will rise toward the upward direction, which is the reaction force. Therefore, the gases and rocket move in the opposite direction with each other with the same magnitude.
Moving on to the next example. Why does a ball bounce? Let's assume that the ball is dropped so that the only force on the ball is gravity, and all moving objects, as we know, have kinetic energy, and the push that the ball receives from the floor causes it to rebound, meaning it bounces back up, and the moving ball has kinetic energy. And this example can be described by reversible statements, which is the ball is pushing against the floor and the floor is pushing against the ball.
The next example of Newton's third law is jumping on a trampoline. When we jump on a trampoline, we exert a downward force. And according to Newton's third law, it states that when two bodies interact, they apply forces to one another that are equal in magnitude but opposite in direction. So, the trampoline will exert an equal amount of force but in upwards direction that will send us high into the air.
And that's all from us. Thanks for watching.